Hey friends, it's March 8th, 2023, and I'm starting with a screen showing board games based on the theme of tank battles, which I thought we'd kind of left in the 1900s. I had no idea that by 2020s we'd be having tank battles for real. That seems very retro. Seems like we're not evolving. We're just sticking in our ruts, right? But let's talk about the evolution from a square grid to hexagonal grid. It's not like all these tank games use hexagonal grids, only some of them do. And like here's an example with an hexagonal grid. So what's a three-dimensional correlate of an hexagonal grid? Like if we're not doing a board game, we want to get out into space. What's the correlate? And I'm saying it's going to be rhombic dodecahedron, basically. These are the sort of the correlate of squares in 3D. These are in 3D, the correlate of squares is cubes, obviously. But the correlate of squares when we go to hexagons instead of squares, so I should have said the correlate of hexagons on a 2D would be 3D rhombic dodecahedron. Oh, look, I have an icosahedron inside. What do you know? So, rhombic dodecahedron. Now, people say dodecahedron all the time. Well, they don't actually. We don't talk polyhedron much in general. Go to Chat GPT-3 and tell it to tell you stuff about polyhedrons. It's time to learn. And a lot of people are frustrated with the whole Greek vocabulary. It's like hedron, what hedron? I used to tell my students, go wash your hedron, i.e. face. I'm trying to link face and hedron. Hedron, poly, many. I don't think we're trying to get rid of poly for many. I think that's entrenched. Polyamorous, polygamous, polyandrous. There's a lot of polys. Some of them are kind of like, not sure we like those polys, but chemistry, poly this, poly that. All right. So what does this take us to, though? When you closest pack, or when you pack together, I should say, rhombic dodecahedra, most people mean the pentagonal. When they say dodecahedron, they mean the platonic dodecahedron, but I'm talking about this one, right? It's got diamond faces, 12 of them. These pack together with a sphere inside of each one, and you get like this picture. This is sphere packing. These could be rhombic dodecahedra. They're all smashed together without gaps. Or if there are spheres inside of each rhombic dodecahedron. So there are gaps between the spheres. We can study those. But think of this rhombic dodecahedron as having a ball inside, a sphere, and it will touch neighboring spheres. If they touch, they can touch at those kissing points, they're called, at the center of each one of those diamonds. So every rhombic dodecahedron is surrounded by 12 neighbors, unless you're an edge case somehow, like you're not in the middle of it. But if you got an ocean of rhombic dodecahedra and you pick one at random, then you've got 12 neighbors, and the 12 neighbors are at the corners of a cuboctahedron. And this is a little bit misleading because of the two colors, in the sense that really all these edges are the same length, and in Zoom we use color to distinguish lengths, and the blues and the reds are close to the same length. So this is kind of a hack. This is kind of an approximation, but that's okay. It gets our point across. These beautiful hubs that can take so many sticks. The ball and magnet approach is an alternative, which we've explored. But this is 12 around 1. And what we've been doing on Math for Wisdom is Andreas is doing a very high dimensional schema for something to do with Dinkin diagrams. Actually, before I get into that, let's just start up Jupyter Labs. So part of what we do on this channel a lot is we keep diving into how do you do hands-on math with this kind of stuff. Like we want to do 3D, but we also want to do mathematics. And 3D and mathematics, of course, they go together. And then there's 4D, 5D, 6D. any number of Ds that we can project down to 3D if we feel like it, like the tesseract, four-dimensional cube, stuff like that. Except what I introduce in this channel is an alternative namespace where we don't use the word dimension in exactly the same way as, say, the mainstream do. The mainstream mathematics has a very codified meaning for the word dimension that has to do with right angles and linear independence and all these kind of concepts, Hilbert space and like that. And what I tell people is that there's not just one ring to rule them all when it comes to dimension talk. There's a competing dimension talk that comes out of the synergetics, which is what I specialized in a lot of ways. And in this competing discourse, you could say competing, you could say cross-fertilizing. Like in what sense is a rose competing with a tulip, right? I mean, you got two kinds of flower. Do we have to say they're competing with each other? I don't think so. There could be symbiosis. So in a symbiotic geometry, the Bucky geometry, we call this 4D. Actually, this is a special case tetrahedron, so it's got more dimensions. It's got mass, it exists in time, it involves energy. But sort of the Platonic, stripped of all that, I don't want, these would just tumble everywhere. These balls in here are not glued in. Almost dropped them. But this is a special case tetrahedron full of little balls, you could say. That's more dimensions than 4 because of all, we're in time and space at this point. But if you strip all that away and you go back to what we would call the Platonic tetrahedron, let's call it that, pre-frequency is what Fuller would call it. That's 4-dimensional because look how much it's just radiating that sense of 4-ness, right? To have a volume, to be inside something, to be contained, and don't we feel contained in the universe somehow? Is the universe a container? Is a dream a container? When you're dreaming, are you contained in a dream? There's a sense of being contained, being inside, right? So what are we inside of? A cube is a too complicated shape. You might say a sphere, but maybe a sphere is a high frequency something. In other words, it's got a lot of features. A sphere is perhaps approaching infinite features as opposed to, depends if you believe in a continuum or not. So in our particular namespace, a sphere is complex. Simple, tetrahedron, the simplex, 4D, because it has 4 faces, 4 corners, and defines containment. And we would say that space is containment. So it's a different namespace is what I'm saying. So here we are in Python, and this is the shape. This is the cube's mid-edges as drawn by Andreas in a program called Math 3D, or you can go on the web and in the cloud you can draw these things. And it's from the center of a cube to the 12 mid-edges of the cube. And those vertices end up being the same vertices as we're looking at here. It's as if every corner of the cube you chop it off and you get like a triangular face. So there are 8 triangular faces and 6 square faces. And what we've been discussing, although Andreas is talking about a model of higher dimensional Lie algebras and stuff in traditional dimension talk, but it just so happens that the model that he comes up with is something we also find in the Fuller literature, where you take two 120-degree paths, you could say, and end up at a 90-degree difference from where you started. So let's show what that means. I think you can see if I orient this correctly, which takes a second for me to find actually the 90-degree, let's see, let's get this right for the camera and show 90 degrees here. There we go. So there's a 90-degree angle starting here, going down and going out to the right. You can see that there's a 90-degree difference here between this one at the top where I'm holding it and over here. So there's a 90-degree difference right there. Now I'm going to go from this ball to this ball using two pathways, two 120-degree pathways. So you can see there's hexagons. These are 4 intersecting hexagons. And if I go 2 balls, 1, 2, that takes me to this ball. And then if I go another 2 hops, 1, 2, those are what we call 120-degree turns, right? Did I do that right? So we're starting, where are we starting again? With 120, with a 90-degree angle. So I got to find my 90 degrees. There we go. So we're starting there, and we're going like 120 degrees and then 120 degrees. The main thing is we're jumping around sphere to sphere inside a closest sphere packing called the closest sphere packing, or cubic closest packing is what it's called, CCP. Not to be confused with the Chinese Communist Party, although I always do confuse them just because it's funny to do. And so this is more how it looks. There is that same, this thing is embedded. This is called rhombigon, and it precedes Zoom Tool, I think. Obviously, this is the more sophisticated space age version of this kind of clunkier thing that's a little harder to work with, but same idea, right? And this matrix or lattice could just go on and on. We could call it a matrix, isotropic vector matrix. And it's every node in this, you could consider the domain of a rhombic dodecahedron, or you could say the rhombic dodecahedron is the domain of each sphere inside this sphere packing that we call the CCP. Or if we make the spheres disappear and just connect their adjacent centers with rods or vectors, that's why Fuller calls it the isotropic vector matrix, because all of these vectors are the same length, right? Whether they're radial, like whether they're coming out from a sphere or connecting around, either way, it's the same lengths. And like I said, this is a little deceptive because it shows 2 different lengths, but you can't really tell, right? Now, if you use an all green zone rods, you can make a true cube octahedron the way we want, but don't need to do that. So that's what we're talking about with on Math for Wisdom. We're talking about that. I appreciate Andreas kind of talking across this bridge between higher dimensional, mainstream, 3D, 4D, what I call extended Euclideanism, practiced by, say, Donald Coxeter at University of Toronto. I mean, he just stands out as like a paradigm practitioner of extended Euclidean geometry. Also, and that's who synergetic. Why I bring him up partly is that's who synergetics was dedicated to. It's like Fuller was aware enough to know that in his own time, this guy Donald Coxeter was kind of the epitome of another paradigm other than synergetics, where we use the word dimension a little bit differently. So here's Andreas in his channel using the 4 intersecting hexagon arrangement of straws, again, to talk about something involving Lie algebras and going from one dimension to the next. He's also talking about slack as an important value in his system, and I don't think he's consciously or intentionally, we should say, trying to connect to the subgenius group, but I bring them up a lot, Bob and so forth, and am connected with this. And slack is very important value in the subgenius world, and I think means kind of the same thing. Slack is an English word after all, but in the subgenius world, we create slack for ourselves. It means enough freedom to go on, like breathing space, elbow room. It's like when you feel like you're being crushed by commitments and responsibilities, not necessarily of your own making, but just to stay alive. You feel like you don't have any slack. By the way, I'm scrolling through a very beautiful cemetery here nearby that I hadn't visited until just a few days ago, called Lone Fir. And this is the dog, Sydney, who is in exactly this pose, exactly right down to my left. So that's what I see to my left. anyway, here's Andreas talking about Slack. But again, just like when he's talking about the Lie algebra stuff, it's in a whole separate namespace, and these, I would say, are somewhat tenuous links between whole different like lineages and traditions. Subgenius and synergetics on the one hand, and how we're using the word slack and dimension, and how Andreas is using the word dimension and slack. They're different, but there's overlap. There's like gears, kind of a meshing there, and I'm finding that useful and helpful because I want to establish these bridges. I want, what my goal is, what my agenda is to have Fuller's dimension talk not be considered so naive and so hopeless in terms of not conforming that we can just give up on synergetics and move on without considering Fuller further. And I think this kind of is the agenda of a lot of universities like Stanford, which has the whole Fuller archive. But if you ask people if there's courses available, if you go to sort of the philosophy or even a math department and ask about Fuller, you're probably just going to get laughed off. It's like, we don't study that woo-woo stuff here, that sort of crazy Bucky stuff is not something we need to study. And I'm saying, no, the second generation of Buckio files or whatever has come along by now, and we have saved synergetics from the ash heap of history quite successfully. It is, I think, destined to inform game world and all kinds of things. Its architects are going to know about it. Visual artists are just going to pick up on what we call the concentric hierarchy. You kind of can't help it once you start to understand it. It starts to make too much sense to just throw away. And a lot of people don't want you to get to that point of where it makes so much sense you can't throw it away, because they don't want Bucky to be disruptive. I mean, he died in the 80s. Why should we allow the Bucky lineage to continue at all? And I'm saying, you probably don't have any choice. We're here to stay, that kind of thing. So let's work together instead of working apart. Let's come together and collaborate, even if you're on a different wavelength. Because I'd say, like the Zome people and the Zome tool, they talk about Bucky a lot, but I rarely find anyone in the Zome world who understands about 4D the way Bucky did. They're very stuck in Tesseract, Hilbert space, higher dimensions, the usual mainstream stuff, which I have no problem with. It's just, if you're gonna advertise that you have connections with Bucky, learn what 4D means to Bucky. Don't think it means Tesseract or 3D plus time. If you stick with that, then I just think you're being very lazy. It's time to stop confusing the Fuller namespace with the Einstein namespace or the Coxeter namespace. These are three distinct namespaces. I think people have this prejudice that there's only one universal language called mathematical language, and there's no such thing as different language games inside of mathematics. And I say this is very wrong and a very naive and unsophisticated view. So you should read your Wittgenstein or something. And if you're in the university and they're not teaching any of the Bucky stuff, you are being ripped off. That's my point of view. All right then. Talk to you soon.